So working with similar figures, we're going to talk about working with dilations. And we want to be able to verify experimentally the properties of dilations given a center and a scale factor, and to calculate and interpret the scale factor for dilations of figures, and determine the unknown measures of the image or pre-image. Dilations. So we need to understand that what we're going to have are some elements here. We're going to have an image, a pre-image, and so just assuming ABC here is my pre-image, and then we're going to have a dilation, which is going to be either an enlargement or reduction from a center of dilation. So here I would envision, hopefully that you can tell that what has happened here is I have an enlargement, and it has started from a center of dilation, which was going to be this point right here. But anyway, just so showing you that there is an enlargement going on there, and the scale factor is what we'll do is determine what is the scale factor from the original image or pre-image to the image. And we'll use proportional reasoning, which is in many ways the cross product property. But for that scale factor, it's that constant ratio between the distance from the center of dilation to the point on the image and the distance from the center of dilation and the corresponding point. Whew, that seems like a lot, right? But let's just, if this was 3, AB was 3, then we would hope that CD would not be 3, but would be 6, because it was times 2. That was my intent. And then if 80 had been 4, then BC would be 8, because it would have expanded by times 2. But we'll do some more examples here, but just seeing that, it's going to be just an enlargement or a reduction in size based on a point of dilation or a center of dilation. And we will work with this here. Okay, when we start talking about the properties of a dilation, a dilation is going to be a transformation. And here's my start for my annotation to document or to be able to identify a dilation. So it's going to be a transformation on the plane where point P on the plane is assigned to a new point. So N is going to be what you're multiplying by to get to that new point. So looking at this, so Q would be my center of dilation. So I'm going to have a dilation. Q would be my center, and N would be the amount that my new image is going to be multiplied by. So if we look at an example, so what we have here is we have a line segment SU, and is dilated to create S prime U prime. Okay, so here's our SU, and then here's our dilation, and it's using point Q as my center of dilation. It wants to know what is my scale factor. Well, let's look at some of these things that's occurring. I can say that to look at it, I know that if I just pick my segment here, so I'm going to pick the measurement of QS, and then I'm going to pick the measurement of Q prime S. So my dilation is going to be equal to some factor times my original image, or pre-image, sorry. And I know that QS is the length of 4. No, QS prime, sorry, my new image is going to be equal to 8, right? Just the length. That is going to be equal to some factor, right, times my QS segment, which is 4. So if I just do some isolation there and I just divide by 4, I can tell you that my growth factor is going to be 2. It's a dilation of 2, scale factor of 2. So if I'm thinking about the dilation is going to be from point Q with a scale factor of 2. Now, I think you may be able to look at this and say, oh, this is 5, this is 5, then it's double, so it's times 2. But it won't always be that recognizable of a number, but just sort of thinking about how can we calculate those dilations. So I might be able to say that I could have determined that my factor, and I guess if we think about it, n is my factor. N is going to be equal to my image divided by my pre-image. So we can use that when we were talking about reduction or enlargements. But what kind of properties were maintained in this process? Well, we did preserve, think about it, the angle has been preserved here, right? The angle remains the same. Parallelism, well, this line is parallel to this line as the enlargement or the reduction occurred. The points remained linear, collinear, and then the orientation of the segments remained the same. The orientations remain the same. But we do create this new proportional side lengths. That was something new, the length, the proportions there. So understanding what is maintaining, we're maintaining our orientation and our angles mostly. Let's see here. So let's try for another example. Okay, so as we look at this, not drawn to scale, this rectangle LMNP was dilated. Now we can figure out the rule, and we're going to start filling in some of the information. So remember that when we're talking about a rule, the rule is going to be dilating, and then you're going to have your center of dilation, and then you're going to have your scale factor, and we called it Q and N. So it looks like if I'm looking at this, I would say that, hey, it looks like the anchor point that it never moved was going to be point P. So I think its center of dilation is going to be point P. Now what the scale factor is going to be, I don't know for sure, but what I can do is I can say, well, we said that the scale factor could be the image segment divided by the pre-image segment. So here I have the new image segment, I have L prime M prime, and I could divide that by the pre-image LM. So again, the scale factor is going to be the image, something from the image divided by the pre-image. So here I know that I have the associated corresponding sides. So I have L prime M prime divided by LM. Okay, and then we can decide that it's identified the lengths of 12 divided by 4, which is going to be 3. So my factor, my scale factor, should come to a 3. So I have determined that this is going to be a dilation, center of dilation is point P, and then the scale factor is 3. So again, LM is 4, L prime M prime is going to be 12, which is 3 times 4. So if MN is 6, I am looking for the length over here, which is going to be 3 times 6, which is going to be 18. And I can identify a lot of missing parts here, of course. That is going to be 6. This is going to be 12, just because I'm doing the math. And then if this is 4, this is going to be 8. So I'm able to fill in some values there and still determine what things are. But mostly I was able to identify quickly the scale factor and some of the associated links. And I will say that this is an enlargement because the scale factor is greater than 1. Now beginning with this example, it looks like we have our pre-image is going to be triangle pre-image is going to be triangle CBD, and then it looks like the other one is going to be getting smaller. So my new image is going to be that triangle. And I want to figure out what my dilation rule is. And what I can do is I can say that, remember my scale factor, so I'm going to be looking at a dilation. And where is my point center of dilation? It looks like it is going to be point Q again. And then what is my scale factor? And we said that my scale factor can be the pre-image divided by the image. So it looks like I have some associated sides that I can work with. I have 18, BC, the new image, B prime, C prime is 18, and BC is 36. So if I take the new image of 18 and I divide it by the pre-image of 36, it looks like my scale factor is going to be 1/2. So there we go, we have 1/2 is going to be my scale factor. And then what are some of the unknowns? The measurement of angle. Well, we said that the measurements, angles are preserved, I do believe. So if I do the math, I should have found out that this angle right here should have been 95 degrees. So as we retain our angles, the angles are preserved, so this should be 95. This should be 51, this should be 34 degrees. And for my scale factor, again, if BD is 22, 1/2 of 22 to get B prime, D prime on my new image is going to be 11. And let's see, do we need to fill in any others here that I may be missing? We should know that this should be 3, this should be 2. Total length, of course, would be halves and doubles. But just looking at what I'm able to fill in based on that. So yeah, so here's my dilation rule. My dilation rule is going to be center of dilation is Q and the scale factor is 1/2. Okay, so one last example here. So it says this rectangle, WXYZ, was dilated to create W prime, X prime, Y prime, Z prime. So it looks like we have gone from this point down to that point. I can say that looking at this, it looks like our center of dilation is going to be point G. So I have dilation, center point G. And now in order to figure out my scale factor, it is going to be the new image divided by the old image. So I've given some links here. I could say that it looks like we have GZ, that's my old image, and then we have GZ primed. And it looks like GZ is going to actually have been 9, right? 1.5 plus 7.5 right here. And then GZ prime is going to be 1.5. And when I do that, so I'm going to find that is, I believe, 1/6. So my scale factor is going to be 1/6. So now when I'm looking at my new WX, from my old WX, it's going to be my old WX times 1/6. So it looks like W prime X is going to be 3 times 1/6, which is going to be 3/6 or 1/2. So that length is going to be 0.5 units. Now, there's another way to figure that one out using the cross product property, or your proportions. So I have the proportion of over, right? I have the new image, the image over the pre-image, and then I just pick the other image over the pre-image, or pre-image. So the pre-image and then the new image. And then when I fill everything in, it turns out that I have 1.5 over 9 is going to be equal to this value, which we don't know yet, divided by 3. And if you were to do the cross product property, right, do something like that, turns out that that is going to be equal to 4.5 equals 9 divided by the coefficient 9. And then it tells me that that length is going to be equal to 1/2. So there you go, 1/2 units. So I could use the cross product property and a little bit more formal way to identify the relationships and determine the scale factor and future lengths. So looking at dilations, we wanted to verify and experimentally the properties of dilations. Dilations, given the center and the scale of factor, calculate and interpret the scale factor for those dilations of figures, and then determine the unknown measures of an image or pre-image of a dilated figure given the scale factor. And just remember that when it comes to a dilation, it moves every point of a figure other than the center of dilation a specific distance based on a scale factor. If scale is greater than 0, okay, so the scale factor is going to be greater than 0. If it is in between 0 and 1, it's going to be a reduction because that's taking a portion. But if it is greater than 1, it's going to be an enlargement. So there you have it, working with dilations using the formal proportions, identifying the center of gravity, and of course the growth or reduction factor.